The next thing we have to build is the cap for the bottle. That one is the easier one. And after we finish building the cap, then we will go ahead and build the threading for the bottle and the threading insert for the cap. So let's zoom to where our cap is, and let's actually turn on, for example, layer 1. Actually, we can just go to layer 1. So I can, for example, see where all the horizontal lines are, because essentially the cap has to flow over it and fit on the bottle. So what we can do actually is, for example, start by copying out one of these rings, because then we have already the correct height, and then we start adjusting the scale, make another copy, move it around, and then step by step actually build the same framework for the bottle, just for the cap. So I start actually with this ring. I can press Shift D and then press Escape, so I do not move actually the ring. Press M and then move it to the next layer below. So I simply have my wireframe model for the cap on a different layer than, for example, where the bottle is. So this lower ring, for example, is already perfectly positioned where the maybe it might be. We'll see later for the fitting. But for the moment, let's actually change first the size. So this one, for example, should be roughly 38.2 millimeters and 38.2 millimeters. Okay. And then we can make another copy of this one. So Shift D and again Escape. And we change the dimension this time to 40.5 millimeters to 40.5 millimeters. Okay. Then with Shift and left mouse button, we can select both. Press again Shift D and Escape. And then actually we move this roughly 2.3 millimeters up. So G, Z, period, and then 0, 0, 2. So just pay attention to kind of like the values you see up here. So you see that because a meter is the main unit, and we want to move it up 2 millimeters, so you have to type in period 002 and enter. Perfect. Let's go into side view. You see that this is kind of like the bottom part of the cap. Now, this ring I selected right now, we can make another copy. So Shift D, Escape, and then, for example, this one we have to move up. Then the whole object is 10.8 millimeters high. This one is already moved up 2.3 millimeters, so we have to move this one up 7.5 millimeters. So G, Z, and then 0, 0, 7, 5. Okay, so let's double check. I'm going to select this lower line, Shift D, and then Z dot 001. No, actually, this is this. 1 centimeter. Oh no, actually, yeah. And now we can see this one got miscalculated. Wah wah. Simple math failed, so not a big deal. We can simply move this one up. So we have actually vertex select turned on. I click on the blue arrow, move this one up, move my mouse to this other ring, hold Control key, move my mouse till it snaps to a point, and then I release my left mouse button. Then I can release the Control key, and good. I can select this one and delete it. Okay, perfect. So we have, for example, up here another small ring that goes in, and it has a dimension of 30 millimeters. So again, Shift D, escape, and then here we type in 30 millimeters. Okay, and this one goes down actually a little bit. So let me measure the distance, which is roughly 1 millimeter. So again, Shift D and then Z, and now we type in -0.001. So you see it goes down 1 millimeter. Okay, so this is again kind of like the framework for our ring. Those are, think about it like hard edges we can use as a reference to shoot for. Now we have to build at least one cross-section view. And we can select one of the lower rings and then Shift S cursor to select it, so that actually my cursor is right at the same horizontal level and also centered at the ring. So when we create then our next object, another spline, it will be perfectly centered inside the ring. So now we can go ahead, Shift A, curve, and let's add a Bezier. Zoom out a little bit, go to top view with 7, tab, select everything. Actually, this might be good to show like two different ways how we could scale everything flat. So I could select this one, point select is turned on, G and Y, move this one down, hold my control key, move my mouse to here, and you see it snaps along the y-axis to the same height where this point is. Okay. I could also actually in object mode, and you see here this one is 22 centimeters, simply say 0, then this is actually artificially compressed. See the scale factor is 0 there, and then I go to object, apply, scale. If I go into edit mode, it's also flat. Alternatively, what we also can do is, for example, select everything, press V and then vector, and then the handles will line up wherever actually the other point is, so they face them. And in this case, it will also result into something flat. The last step with V is the one I wanted to use anyway, because I want to work with linear lines first. So my 3D cursor is still at this position, and I can click on this point and either inside transform control points write 0, so it snaps actually to the same location where I positioned my cursor to, or I could say Shift S, selection to cursor. There. Then this point I actually move in a little bit more, and then let's zoom in. Let's focus on it, and then here is actually a point on my ring, so I can click on the arrow. Also, you see I have normal turned on, and you see the normal actually the Z is always along this line, and then you have X and Y, and this all flips basically based on what setting you're using. So let's undo this one. So maybe here now I have global. Now I can go move the red arrow till I hit this area, hold control key, release my left mouse button, and it's snapped. But I really love actually working with the normal when I work with spline, so I switch back to this one. Now I can press E and then Z and hold control key and snap to it, and press E and X, hold control key and snap to it. And this perfectly worked out because all these rings basically are either above each other or next to each other. And then one E and Z, hold control, snap, E and X, control, click, E and Z, control down. And now the next one should be where the 3D cursor is, but roughly here. So EX. Now I could, for example, say SX and 0. Whoops, but I have to go first to 3D cursor. So I scale actually to this 3D cursor, but only along the x-axis, and 0 works. Or, because those are 2 steps, I could simply go to control points, 0, zip, there. Perfect. Okay. This one actually will have a small radius. So I could visualize this for me so it's a little bit more helpful. Create a circle. And I think it is roughly a 2 millimeter diameter. So I could press F6. I have a different key mapped, so that's the reason why you don't see that to pop up. And then I type in radius 1 millimeter because that's the dimension for 2. And then rotation 90 degrees that I know, so it's actually flat on our screen. Where is it? Where's the ring? Oh, 1 meter, 1 millimeter. Forgot to enter this one. Okay. And then can bring this one into the position. Then I can press the Y arrow, hold Control key, move it to this corner. It snaps. Press the X key, move my mouse to here, hold Control, and release the left mouse button. Then I release the Alt key. And you see now we have this one positioned. And this is very helpful now because it tells me maybe how I have to bend certain parts of my curve to kind of like get this result. So I think now we can go ahead and start sculpting our profiles a little bit. So for example here, this point, I would like to move over to the right a little bit by 1 millimeter. Currently I can't really use the normal view. I could go to global and then push it over by 1 millimeter. But while still with the normal widget active, I simply could write GX, so move along the x-axis, .001, 1 millimeter. Perfect. These 2 points I actually would like to be aligned to those lines, so those handles. Because currently you see with vector we get, linear transitions. And if I select this one and say aligned, you see it aligns it with the green line. And what I can do now is I cannot actually move these points up and down, but I can drag them out further. But the way how it looks right now is actually very pleasing. It's a nice S transition, so I keep it. Good. For example, here I would like to have a ring. What do we do? It's not really a big deal. We have to add actually another point. So 1 point here, 1 point there, and then we also work with the handles to sculpt that shape. I'm going to select these 2 points and then I press W and select subdivide. So you see actually this added another point, and then this point I have to move right to where this position is. So it's basically at the midpoint of this arc on top. So either GX and then Control, and then here G and Z, and hold Control and click. Perfect. And these 2 points, select, align. It's going to side view because it's not necessarily perfect yet. So I would like them maybe to come in a little bit close. Oh, there we are. Maybe this one will tick up. Maybe tick back. This looks good. If, for example, you would like this to be more evenly spaced out, see, I was actually moving each one at the same pace. Let's see what happens when we press S. And you see, because they're aligned, they have to stay aligned. And with S, actually, I scale them towards each other, but they can't really look at each other. So with S, I scale them simply in or out. And it's pretty fantastic. And actually, it works with both at the same time. So I can nicely scale them so I get this nice arc. Really good. let's take a look down here. Actually, I made a small mistake. This one doesn't even have to be there. It actually has to go more there. So I need kind of like something circular, and then later the metal has to bend in a little bit. So let's see how we do this. I'm not going to make a copy. I'll just leave it. Okay, so you and you, maybe, let's say automatic. What does automatic mean? You see, actually the handle size adjusts automatically. You can just only move the point. You can't really do much with the handle. Obviously, if you do, then you override the type of the handle. This one here, I'm going to set to be aligned. And then actually this point, I slightly move up. And then I try to see maybe where do I have to put these points. So I might actually get a nice kind of like rotated circular shape. And it could work, or the automatic tool here doesn't work as I hoped. Not a big deal. So let's override the automatic to align, so I can actually now rotate everything. This one here I push out a little bit. This one I push up a little bit. No, this is a metal part. For example, that would be bent by a shape. So this will be machine made. So we don't have to be 100% super accurate. We could simply maybe suggest the shape. Like this. Okay. That doesn't look too bad. Let's preview the result with a solidify. With a screw command. Let's move this one actually maybe to, no, actually let's not move it to a different layer because it's still the profile. But with Shift H, we can hide everything else. And then we only see our cap. That is actually pretty good. So, and then we can actually turn off the screw modifier and remove it because the result is pleasing. With Alt H, we show everything again. And our first step, crafting the layout for the profiles, is done. We are now ready to generate the polygon model for more sculpting. Again, the reason why we do this is we can use splines to quickly create nice shapes and flows, and then even use actually like the screw feature to, for example, lathe it around the z-axis 360 degree. But we can't really locally sculpt on those objects because they're not really there. They're more interactively generated. So we have to rebuild this one. Or actually what we can do, I'm going to show you this in contrast to the way how we build the model. We can also convert actually this object already into a polygon model. So I'm going to press Shift D, Escape, M and 4. So we make a copy. With Escape we do not move it, and then with M and 4 we move it to the layer 4. And we have this object selected. So for example, here I type in 32 and I go to Object and say Convert and then Mesh from Curve. Let's turn this one off for the moment. Okay. And then go into Edit mode. There's our design. It doesn't look too bad. The problem, however, is this is actually very, very dense. And you see also here, this is very dense. If at one point we want to change a small part, you have to work with all those cross sections and evenly adjust them. That's possible, but it's going to be very labor intensive. So this approach doesn't work, but that's not a big deal. Simply let's undo everything. What we have to do first is I'm actually setting the levels to 6 because this is going to be again the low resolution I only need for my subsurface modifier and later in T-splines in Fusion to simply get a nice circular shape. And then we go to the curve data, and this one we actually can set to 2. From the top you didn't see much, but let's take a look at here, and you see when I set this to 1 or 2 or 3 or 4, you see you get more steps. So this is similar like the subdivision view levels, but just for NURBS surfaces. And this result, for example, with 2, maybe let's go with 3. That might be not too bad actually to work with. Okay, so now actually we can go to Object, Convert, or you press Alt-C, and then let's go into Edit mode, and there you see what we have. Okay, not too bad. Good. We have to add a subdivision surface modifier, maybe level 2 or 3 for the preview. Let's turn on projecting the cage onto the mesh, and let's take a look at the side. No, doesn't seem to have any issues. On this layer, let's turn off the screw modifier for the curve, and then let's make an overlay because we will see that this object actually shrank, and that is because with the subsurface modifier we only have 6 actually vertical cross sections. It simply will shrink it down dramatically, but this is not a big problem. We can simply select everything, and then we press S and Shift Z and scale it out so we get a close match again. Okay, perfect, or nearly. So you see actually that it doesn't necessarily fit everywhere as good, and I have to scale all these points right now, so possible, but this might actually be a little bit too much work. So what I simply do, I make myself again a copy of the original one, and then set this back to 6. So view this one, and then here we say 2 in this case. 3 was just a tick too dense. And then convert. So now we have a lot less points. Let's show this layer as an overlay. AA, S, Shift Z, move it out. Yeah, so now there we have less points actually we have to take care of. Okay, so what we can do now is, so this, as you can see in a low polygon cage, is vertical, but if we project it onto the subsurface surface, you see this gets crooked. Not a big deal. When you have more than 2 points in a line, it will actually straighten the surface. So you see if we add, for example, a loop cut and a loop cut, this area gets straight, and then to there it starts bending out, and then there it bends out. So let's go down to this part here. Let's maybe select all this and see what we can do to maybe help a little bit. So G and Z to center it a little bit, and then S and yeah, when we just scale it out a tick. Actually, those, for example, we scale inwards. Oopsie. Obviously not this way. Yeah, there and there. So I select those edges and then I go to mesh, select and edge loops there. And then S and I shrink it back there. And for example, I can select this and this and then do the same, select the loop. And G and Z, for example, move it down. Okay, this is actually obviously not 100% accurate, but this is a machine part. And all we do here is quickly make a concept. And for this, actually, this result is pretty decent. With Alt left click, you can also can click on the ring, or is it Controlled left click, and then G and Z move this one up. For example, let's take a look at how these points they are there. Maybe this point actually, this complete loop I remove. Curious how this looks now. You see that will be a bigger transition. That's fine. But now I can take this loop and actually push it down a little bit. Take this loop, push it down a tick. Take this loop, push it up a tick. There. Then we get a nice soft transition. And maybe this one we scale a tick there. And this one maybe move up if we want to. And this one we can G and Z move up a little bit. Yeah. And you see that wasn't too difficult to quickly adjust. Let's take a look at this area here. So we have this midpoint. We can actually remove it because what we simply can do is we add a small loop cut here with Control R onto this line, move it in there. Obviously, if you do this, you want to try to make those distances kind of equal. So think about those as fillets there. Now we have a nice transition there. And this actually does not look very circular. So this is not very pleasing. So let's see what we can do actually. And I'm going to select this edge and, for example, completely remove it. Select this edge there, and then G and Z, for example, move it up till we hit this point there. Select this edge, clean it out. Okay. Let's take a look. Okay. And maybe this line I move up a little bit. So there are two ways now. We could either, for example, try to sculpt this part. So we could select this edge, and then we could, for example, with the Bevel command, so this is Control B, and then you have to move your mouse away a little bit. And then with the mouse wheel, we can add actually subdivisions, so more steps to, for example, sculpt this a little bit rounder. There, okay. And then with F6, we can open the dialog. And for example, here we could type in maybe for profile 0.6. So this maybe looks a little bit rounder. Okay. Up here, maybe I would like to have 2 loop cuts to straighten that top surface. Let's take a look at before. You see how this actually dips down, and then with the loop cuts, it's a little bit straighter. Okay, so that's one way. But the problem is I have now actually added all these loop cuts or subdivisions, and a smarter way would actually be select this edge and let's set this weight to 1, and then actually before we do the subdivision, we add a bevel command, but just for the weight, actually with 1 millimeter, maybe 5.6 profile. You see, this is actually the same command like for the when we actually add it directly to the mesh. And maybe 0.8 millimeters, no, 0.9 millimeters if we want to hit, for example, that profile pretty closely. 1 millimeter. Yeah. Okay, this looks actually pretty good. So, and as a last step, first, so this mesh looks pretty dense, so we can click this option here, optimal display, and then it shows you less wire lines, so it's a little bit easier on your eyes. And now we could add a solidify modifier to give this part also a thickness there, and maybe 0.2 millimeters. And let's take a look at where this one is being inserted to. Yeah, so this actually goes to the inside. You see here with offset, this grows to the outside, this grows into the inside. Let's check those actually. And yeah, this is actually, ignore this for the moment. We will fix this when we need to. This is, however, actually a pretty good result. And there is actually the problem. These points actually are not joined. So you see here they overlay actually. But for the moment this is fine. We can keep it this way. It's exactly the way how I want. I will come to this at the end of the project to optimize the mesh a little bit. Okay, let's keep the cap this way, and then we can save it actually. But before we do this, let's make one last check. We have to see maybe the height position. So we see here the curves we created are all a little bit too low. Now we can AA, select everything, go to the bottle, and for example move this one up. And then I pay attention to where's my bottle and where's, for example, this arc. Should be maybe somewhere here. There will be a little bit of compression material in between. And there we are. So I think this is pretty good right now. If, for example, we would like to see in edit mode actually half of the model, we can select this part of the model for the cap and press H to hide it. And then you can quickly see kind of like a cross section. Looks pretty good. Okay. Alt H to show it again. And that's it. At this point now we can go ahead and start working on the threading. So let's go back maybe to here for the moment. And I simply select this ring, Shift S cursor to selection, so I could quickly position my 3D cursor to there. And then let's go to the bottle so we can see it from the side. And I shift click layer 5. So I can see what's on layer 3, but I work on layer 5. And I'm going to add then a plane, and then, for example, sculpt it into the shape I need for the threading. And then we're going to use the screw command for the threading. So Shift A, add a mesh. And this plane is going to be very big, so you can press F6. Or alternatively, you could also go to the tool panel and, for example, down here type in 1 centimeter there. Okay, and there is the plane. And then I could press the tab key and, for example, RX90 and rotate the mesh. But the mesh is pretty big, so the threading is roughly 2 millimeters high and maybe sticks out 0.5 millimeter in this design here. So to do this quickly, because this is more or less a squarish format, we could just go to Z in object mode, type into millimeters, and maybe dimension, we type in 0.5 millimeters. Now, because we have a scale factor applied, I don't want that, so I go apply scale. Okay. So why did I do this? Very easy. I can go to edit mode, and for example, move this one out to there. And then I see, for example, so when this is 0.5 millimeter, how far does the threading stick out? And another 0.5 millimeter then actually already reaches this cap. So maybe in my case, instead of making it 0.5 millimeter, I actually will make it maybe more something like 0.75 millimeters. So I can select these 2 points, and then I press GX, a little bit of math. So currently 0.5 millimeter. I want to add 1/4 millimeter, so 0.00025 minus. And if we measure this distance, and it says 0.05. There you can measure the distance, and this is also 2 millimeters. Okay, good. So you find the measurement tool for linear lines, for example, inside the mesh display, and you can just click on 2 lines and then it measures it. You could even, for example, measure angle and, for example, the area of a face. You see all those are 90-degree angles. So it's pretty nice, good tool. Okay. So in object mode, then I move everything up from the moment to there, and I'm going to do the following. I'm actually going to make a copy. So Shift D, and then for example this edge I might actually remove. So I keep this maybe as a visual reference, and then you see there are 2 objects now. So the one that looks like a C, and maybe to make everything a little bit easier to distinguish, I select all these points and then I press Y. Y is actually the split command. You don't necessarily see much of a difference, but if I click now on an edge and then press Y there, and then when I press S, you see you can actually scale those lines apart. So here I scale those S and X along the X-axis, and you see now this more or less looks like a nice layout. So I can use those as guidelines. So I always know where, for example, my roughly my 0.75 marker is. And then I can go back to the first object I created. And for example, go ahead, this edge, we also can delete this edge. For example, I could maybe scale down a little bit so this tapers a little bit. Yeah, so let's start this way. Good. So to create a threading or a thread, we basically can use the screw command. So it looks a little bit cleaner. Let's set this for the moment 64. And here is the screw command. So this basically now decides the vertical offset. You see 1 millimeter, so half actually the height, 2 millimeters the full height, so it's like a 360-degree spin, and then you see it stops where the other one starts, because hence 2 millimeters. If we, for example, type in 3 millimeters, then let's go to this view there, we actually have the perfect space for the other threading to fit in. Okay. Now we also have different iterations. So if we need multiple threadings, and we can, for example, also change the amount of degrees, 180. So with 180 degrees, it's just, well, just half a spin around it. And it's really important that your object center is like at the center of the bottle. So that's the reason why I first created myself my mesh at the center of the bottle, and then in edit mode I moved actually all the vertices outside. So I had my object center point already positioned. And in case the object center isn't positioned correctly, then let's maybe do this as a quick exercise. Zoop. Let's go to here, plane RX there, and let's quickly scale this one down. Let's make a dummy threading there, and there, and there. Okay. So you see, when it's, maybe let's move it to there. So for example, you see this is also not on the x-axis. Okay. Let's add the screw modifier there. And there you see, it doesn't really fit correctly, not the way how we want or and need it. So now we could go, for example, into edit mode and say all those, I think with Alt 0, we can set to 0 of the object. Let me check one thing. Yeah, okay. Or for example, where the object point is, Shift S in object mode to the object origin in edit mode, then switch to 3D cursor and then SY0. So you see we scale it down, and then we can actually move this object simply to the correct position. So X and Y 0. There, now you see it's centered. And then we can comfortably move it up and down along the Z-axis. And then from a side view, we can simply move this one out there. Okay. So I know actually that we have 4 of those threadings and they slightly overlap. So if we, for example, make a 90-degree threading, then actually the next threading below would start and then go to there, and then at that position the next threading would start. But they overlap also a little bit at the ends. So maybe instead of 90 and not 180, we have maybe something like 120. Okay. So I'm going to set my 3D cursor to the selected in object mode. So I center at the object point for this first threading, and I'm going to name this one threading master, because that's just how I start sculpting. And then maybe Alt D, so we make a clone R, and then 90. Alt D R 90, Alt D R 90. So and there you see actually now how all those threadings actually overlap a little bit. Perfect. So 120 might not necessarily be enough. So let's select those 4 threadings. Okay. And then Alt click. So you hold the Alt button and then left mouse button click onto angle, release everything, and then type in 140. And that should actually change the degree to 140 for everybody. And this actually looks pretty good. Okay, but they are touching here, so that's not necessarily ideal. So maybe here for screw, Alt key, left mouse button, 4 millimeters. And yeah, that actually seems better. Now we have a good gap between the threadings. But now the threading is actually too high, and the top of the end should be roughly 2 millimeters below the top of the glass. So I'm going to add myself a small plane there, and then actually this plane I would like to scale up there, And if I put this one to 16 centimeters, it is roughly at the top. Yeah, okay. I would like this one to go down by 2 millimeters, and I could simply type this one in 15.8 there. And this plane currently is visible all the time, it's shaded. So I can, for example, select these two edges, delete the edge, select these 2 points, press F, and then I filled it in, and I kind of like have a outline of a rectangle. So it makes more sense. I could, for example, call this one threading top edge guide. And for example, this other thing here, I could call threading side edge guide. And I just made up these names, so they're logically and make sense to me. Okay, so all these threadings, Jeezy, I have to move down a little bit, because what I haven't figured out yet is actually for them to sink into the bottom part. So the threading should actually come out, but then stop there. So actually, as you can see, the vertical height is not good yet. So with all those 4 threading parts selected, I can go back, Alt, left mouse button, and then maybe try 5 millimeters. Well, there it is. Actually, that's pretty good. So you see from down here, it goes up 5 millimeters. That's kind of like the distance. So let's actually go to grease pencil, ruler, left mouse button, click, drag up. Yeah, kind of like 6 millimeters. Okay, yeah. Escape. Perfect. Okay. That actually looks pretty fantastic. So let's save. It's your best friend. Nothing is more annoying than when the software crashes and you lost all your work. You also see that this guide actually horizontally doesn't match up. That's fine. But for me, what's really important is actually this vertical line. So let me see, where's my master? There's my master. Actually, everything here I will select and maybe move on to the layer below. And then I simply select this one, and move this one to the top for the moment. And where's the master? There. Shift D, X. So I don't move it. M, layer 5. There. Okay. And for example, this one I call now sculpted. There. Perfect. Okay. Good. So I would like actually to sculpt now my shell, so I can add, for example, a subdivision surface modifier, so everything is rounder, maybe a tick more, and you see how round this part is. If, for example, those points I move closer together, so S and Z, I get a different profile for the threading. Instead of being more roundish, it actually is more pinched. That's nice. Let's take a look with the with the bottle, and we see that there's a small gap in between, not a big deal. So what we're going to do now is actually the following. I first have to sink in the threading a little bit inside my bottle, but still also make sure that, for example, the threading sticks out also the amount of distance I need, so 0.75 millimeters. And currently, you see I only have one cross section, I can't sculpt it. So I have to actually at one point apply the screw modifier, but I don't want to have, like in this case, 64 subdivisions I have to work with. Way too much work. So, which is at this point now I have to see if I go maybe with 4, and apply this. Not really enough, so maybe something with 8. And you see, based on how many subdivisions I give, also the threading changes. So 8 is actually, I think, a good amount in this case. Let's give it a try. Apply, and yeah, the points are okay. Good. So under it. So, but before I do this, you see actually with 8 subdivisions and for the screw, and then the subdivision surface modifier, I can already see how much maybe the threading will shrink because I added the subsurface modifier. And let me see, maybe how could we do a good overlay? So this object, I'm simply going to switch to the boundary box, and then I rotate this one maybe to here. And the main reason is so I can actually take a look at it. And then go into edit mode, and what I have to do now is the following. These points, for example, are they inside the object? So let's see. Alt B. Yeah, it actually intersects with the body, but maybe it should intersect a little bit more. So I will move them a little bit more into the bottle. Okay. But as we can see from this view, the rest doesn't stick out far enough. So then I select the other 2 points. And you see this is actually X. I could go to this view and then G and X and then move it to the correct direction. Maybe now here I go to this view and then again G and X. Yeah, that seems to be perfect. Okay, another nifty way how to do this, instead of, for example, rotating this one a certain amount of degrees, we could simply say screw maybe by 64 steps there. Okay, and maybe this one we will give actually this color so I can better see it. And then when I go into edit mode and then I start pushing those out, I will see at one point it will penetrate that surface, and then now it's roughly where it should be. And then I, for this part, can simply remove that threading command. So it's more like a different visual check. Okay, perfect. So this is good. So this part, maybe Shift D, escape, because I would like to keep a saved version of it. So I try to select the sculpted again. You see when you click on there are 2 objects and you can actually switch between them. Also when you hold Control, I think, which was it? Oh no, it was actually Alt. So Alt, left mouse button, you get a menu of what's actually under your mouse. Pretty awesome. So there, select sculpted, and then we move this one to the layer below, simply as a backup file there. And then this one here with 8 steps, we apply, and you see nothing changes. But what we can do now actually is the following. So here maybe we have to move this in a little bit so it doesn't stick out too much. And then here you see we have to move these points inwards. But let's see how this one works. So we can select all these points. You see my 3D cursor is still at the center. This is very important because I scale to the center of this rotation or lathe object there. And then I can press S, Shift Z, so I do not scale along the Z axis, but just X and Y. And then I can scale to the center of my bottle along X and Y, till, for example, the end of that part is inside my bottle. And that basically was it. And you see, you really wanted to nicely overbuild. Otherwise, later Fusion will have some issues when surfaces touch each other and they sit on each other. They really have to sufficiently intersect each other. Okay, so nicely done. So we need 4 more of those threadings. Now, there are 2 ways how we can do it. For example, Alt-D, R90, Alt-D, R90, Alt-D, R90. Then we have 4 parts. And I would like each threading to be added to the bottle. I have to have 4 commands to join to the bottle. And this is actually way too much work. So what I'm going to do instead is simply the following. So where this object center for my threading is, Shift S in object mode, and then I add actually a small empty. And yes, I'm going to make a small circular array there, because this object has to be rotated 4 times. So this empty I rotate 360 degrees by 4 steps, so 90. Doesn't really look rotated because it's just 90 degrees, but it is rotated. So I can click my threading and then say you add an array, turn this one off for steps, object offset, this empty, and there we are. And maybe this one here we call empty array threading, so it makes sense. Perfect. And this one is our for example, sculpted final. So you see now I could go to the bottle and say Boolean union and then type in threading and filter out all the other objects. There is my sculpted final, hit enter, and there it is. This one actually should be on this layer. And that was it. And you see, very easy, just one simple Boolean join command. Because while you see multiple objects, what's happening is in the end we only have one object. Then we smooth it out and then the array creates 4 more visual copies, but it's still just one object. So all the mesh of this object then is added to the bottle. And that's basically how we make the threading for the bottle. So the last step we have to do is now actually to create that compressible material insert for the cap, which we could use to screw the bottle into and then jam the material between the metal cap and the glass so it seals. For a task like this, the best way would be now if we could take a look at the cap but only see half of it. But we can't really use, for example, this cut section view because it cuts through everything. So what we're going to do is we go to the cap there, and for example we add a small cube and then we scale it down there. So now with S, the cube was 2 meters big, so I needed to scale it a little bit. S and Z, this one here I move up a little bit, and this one I move a little bit either behind or in front, but try not to perfectly line the edge of the the cube with the center of the cap, because you see this face of my cube lines up with the geometry lines inside my cap. And Blender is a little bit picky about this one, because also here this object is open at the center point. And in general, it's very bad practice also with NURBS. Second explanation. So let's make a copy and another copy. And let's scale this one. So you should never, also in Fusion or so, try when you want to trim parts to let them rest on each other. And the same is true for Rhino, and the same is true for Alias. It's pretty much very difficult for the software to understand how, for example, this cube should open this cube when the faces, so the bottom face of, for example, this cube, so this face, sits actually exactly on this face. And for the software, math-wise, it's always easier to do this calculation when there is very clear intersection between the two objects, because then the software can really understand that somewhere around here we have to calculate how these objects are intersecting, and so we can just cut all the other stuff away. So that was a little excuse about how to best build the stuff. Let's add some visual colors. Again, I use these colors just because I like those two signal colors, and I very often use blue just for objects, and I use orange for geometry that tries to cut something away. This object I call, for example, let's call this one cap boolean. Oh no, wait, yeah, cut section, for example. Okay. And we can move this cube maybe onto this layer, so it's out of our view, go to there, and then we add another Boolean modifier. Let's keep this one at 3. I will take a tick, but to calculate that would be fine. Cut section, there's only one object with that name, enter, and there it cut it out. Hey, nifty trick. If you want to actually see that cut section material on the cap, you see currently this object has one material, but we can actually add another material to it. So plus, and then Boolean, and over there you see it actually takes the material from the Boolean from this object, which has the material Boolean, and adds it to it. The way how this works, actually, everything that's orange right now, this is actually geometry created by this cube, so it can actually use then the material from that cube to render it along here. So this is actually a really nice way when you want to see like a nice and clean cut section view, and then visualize also by color where you cut. So maybe also turn on auto smooth. See, there's a little bit shading artifact. I just try to fix it. Oh wait, maybe with 15. Maybe 10. That's a pretty bad one. Okay, well, it's not a big deal. It's just a visual annoyance. It's not really that the geometry is bad. Okay, now let's go back to this view. There now you can see what I mean. This is actually insanely helpful, because now I can clearly create and work with the negative space between the cap and the bottle. Also, actually, before we continue, I see there is a problem here. So this actually has to go in a little bit. So this bevel command I remove for a second. This one I apply, and then I have to select. So control click, control click, control click, or in your case, I think again it was all alt click. And then in this case here, everything's selected. Top view, alt B, make a cut section view. There I see how far, for example, this intersects, and then S, Shift Z to exclude the Z axis. And then I scale along X and Y and move all this just a tick inwards. I can also select this edge, for example, and then select and loop. Even when you don't see the rest of the mesh, it is still selected. So now I could press S and Shift Z and scale it back a little bit. So there's kind of like my circular shape. I know the snugs actually or hugs the bottle better. Okay, and we can release it. Oh, what happened? Let's take a look. That's interesting. Why did the Boolean command actually fail? Sometimes when Blender is a little bit picky or so, or in general with programs when they're picky with this command, simple trick, always move those elements a little bit and then see if that actually fixes it. And yeah, so there was a just geometry was too close to each other, and that confused the software a little bit. Not a big deal, we just fixed it. Okay, so I would like to see what the distance here is, and this actually looks pretty tight. So I could measure this one by going to tool panel, grease pencil, ruler, and then click, hold left mouse button and drag down. Ooh, this is not really much. So maybe at least a millimeter this actually should go up. So this is actually 2.5. So everything should go up 3/4 of a millimeter. So what I have to do now is select all this. To make this calculation faster, I turn the Boolean operation off, select everything, and then GZ.00075. So you see 3/4 of a millimeter, enter. Then I can select the cap again, turn this one on. So why do you do this on and off? The thing is, Blender constantly re-evaluates those functions. So even when I just move it a tick, it instantly updates it. And if you want to move it more up, so every time when you move the mouse, it just recalculates. Can sometimes be very helpful, but sometimes also quite annoying. So that's the reason why actually I simply turned this one off. And let's take a look now. Wrong layer. And let's go to the ruler. Yeah, kind of like a millimeter. Okay, good. Escape, T, and save. So now we can build this kind of like the silicone or compressible material insert. And we don't really, with this bottle, have to build an opposite threading. The nice thing is we just build a volume that basically would be pushed or glued into the cap or glued onto the cap inside. And then the threading actually will be molded in a way that there's just a cavity for this threading to go into. So this actually makes this step very, very easy. And I'm going to simplify this step actually a little bit. So let's see what we can do. Let's try not to be too precise. We're just going to simplify this a little bit, because again, what we're going to do right now would be a very, very technical part. An engineer would probably take more care of it. Obviously, if you want to build it yourself, you have to do it. So we make a new plane. The 3D cursor is X and Y at 0. Plane. Going to shaded view with Z, tab RX90, and then, for example, we can move this one over and over there. Okay, and then we can move this one up a little bit, maybe till there. And now I have to match this a little bit. So you can see where actually the bottle is. So should this really be at the bottle, or should there be a small gap actually? And obviously we want to have a small gap. This one should come down and actually should sit on its snock. And you see I used actually the snap tool. So GZ, move it up, and then hold Control key and snap to these parts. Perfect. Good. This edge actually we could subdivide, because then there I have a new point, GZ, and maybe try to see if we can find a point up there. Okay, good. And then select these 2 points, E and X, and maybe for the moment first move it over. Okay, so this internal edge, for example, we would like to remove. So I delete the edge, and then this point, I'm going to turn this one to X-ray so you better can see it. I will simply dissolve, and that just removes the edge. Sorry, the point. Okay. Now this one I move a little bit further, and for example, as you can see, I'll try to match a little bit that angle. Okay, good. That I like. So let's see what the next step could be done. So this and this one, G and X, I have to snap actually onto that surface there, and I think maybe in this case we do a cut section view of this part so I can see if it really lines up, and it does indeed. So if you go into shaded mode, you see actually there is a geometry. So I can actually G and X and then snap to that wireframe model. And then this way, this edge actually rests on the inside of my metal model. Perfect. Good. This one maybe G and X a little bit over, G and X a little bit this way, and looks like this is actually tick too high. Now for compression actually, at least up here, this piece will be a little bit bigger, so the bottle will, the volume actually will press against it. And here we also see, for example, where's the opening. So question now is, do we really need actually to go over till there? Or we could maybe there. So we have this edge and this edge to glue onto, and then here we will have material where actually the glass will press against the compressible material and create a seal. And maybe to make this one a little bit cleaner, we simply as X and 0 with the bounding box line these 2 points up and just keep it this way. Okay, good. This looks pretty good. So this part actually I'm going to move on to the layer for my cap, because essentially this is part of the profile area. So where's my cap? There's my cap there. And then, for example, we could create a screw modifier there. Okay. For example, here again we use 6 steps. I make a copy, Shift D, and move it to the 4th layer. There. And then we will apply this. And then we will add a subdivision surface modifier, and everything will look very soft and round. And that's fine, because What we're going to do now is actually the following. So this edge we have to bevel. So bevel, this one actually we crease so it's tight. This edge down here, for example, we have to bevel. This edge we have to crease. Crease means we sharpen it. And this edge down there, maybe, yeah, let's crease it for the moment. And then this inner edge here, that one we also have to bevel. So you see with the creasing already, this is pretty sharp. Actually, for the moment I creased this one as well, because what we have to do first now is AA, select everything, maybe project the mesh on it, and then S and then Shift Z. Let's quickly scale it back. Cut section view, S, Shift Z, and then maybe in this case here we have to eyeball this for a moment. S and Shift Z. There, these lines overlap. Okay. Good. Perfect. So, what was all this about? So, let's bring this one back. Also, this currently looks kind of wonky because I still have this X-ray on, so let's turn this one off. And now we will add a Bevel modifier. Move it to the top, but only to the weight. And what value do we have here? 1 millimeter. Okay, so this shrank a little bit, so it can't be 1 millimeter. But maybe let's start with it. And how many steps? 5. So let's try to match it. 5. And then this again is actually a pretty good situation where the cut section can work really great. So 0.6. Also then here 0.6 there. And then maybe 0.9 millimeter. 0.8 millimeters. Oh, turn this one off here, this clamp. 0.9 millimeters. 1 millimeters. 0.7 millimeters. Ah, there. So we're pretty close actually to it. Let's actually take a look at this with the bottle. And this actually doesn't look too bad. So you see like all this comes around, but maybe this rounding here is a tick too big. So we could actually then select this ring and then change the value, for example, to 0.5, which means 50% of 0.7 millimeters. And you see that already is a lot smaller. This is actually okay. So I'm curious now, actually, hold on, 1 millimeter. So 1 millimeter actually makes this one nearly perfect, but then this actually is too big, which means then in this case, let's try to find this edge, this one, there. And then let's go back to the cut section view. We simply then adjust the weight here, via percentage, like 10% down, 8%. Oh, you see there it gets closer. 0.7, too much. 0.75. Yeah, there's a little bit of a gap, but you know, you also need to have the glue material in between. And for like a quick concept where there's a visualization, this is perfectly sufficient. When we would render this one, obviously these two shells would intersect, but because the cap is metal, for concept modeling, this is fine. Okay, let's save for the moment. And then let's take a look at this, because this one actually is creased. We don't need this to be creased. And I'm curious now how this actually looks for the threading. So yeah, this comes down. I think actually this maybe could do it already. So let's call this one cap insert. And what we have to do is know the threading. We might actually have to cut out of this insert. So I have to see to make sure that, for example, the orange surface of the cap is always outside and then cuts into the cap insert object, but that those sides still stay outside. So you see actually there is a clear shape. And think about the orange object, the threading, like a knife we're going to use to carve something out. So we can select the cap and then Boolean. Let's save. And in this case, difference, because we do not add actually the threading, we simply cut it out or cut it away. There. Let's take a look at the threading. And this is actually fantastic. Let's change the shading a little bit. You see there are a lot of artifacts. This is just a visual artifact. It's not that the geometry is bad there. And what I was looking for was that here where this is round, we have a very easy entrance for the threading to go in. What does this mean? So let's say we make this one a 1. Okay. This could maybe work as well, actually, the way how I build it, but you might have to force the cap a little bit over the start of the threading. So it's not very comfortable, and that is why, for example, I soften this edge by not creasing or not beveling it, and then we will have a better thinner area here, and the threading will better slide onto it. So let's also give this a material. So if, for example, we would like to see also this with a cut section, we can do the same. So first, let's actually name our modifiers correctly. And then maybe here, different cut section. And we can use actually the same cut section object for the cap. And there we see now kind of like the fruits of our hard labor. Maybe let's add also that other material so it's easier to see. Perfect. How awesome is this? Okay. And now there we have also the insert for the threading and the cap.